Okay, welcome class. I know that most of you are away today on a field trip, so today we're going to do our lesson videotaped version, and hopefully this turns out all right for you. I'm going to forward you the Word document for this as well, so if you can't quite read what's on the board, just follow as best you can in your notes that you can print off, and then hopefully you'll be able to see what I'm writing. Okay, so today we're looking at generating a system of equations. This is chapter 7.1. Your homework for today was actually the review, chapter 6. So you're going to be writing your test. Next class, I'll assign that. But today we're just doing the lesson for this, so we don't have any homework on this. Our chapter 7 is going to be almost entirely on generating systems of equations and ways to solve systems of equations. So let's take a look at what the definition of a system of equations is. It's two equations. Okay, so we have two equations with two variables. It could be x and y, it could be a and b, it could be s and l, whatever we want. Okay, so we can pick the variables. It doesn't just have to be x and y, it could be anything. But we're going to pick those two variables and set up two equations, and then we're going to be able to solve those equations. Okay? We call a system of linear equations, we call it a linear system. Just another definition or another key phrase there for you. Solution of linear systems is a pair of variables x and y that satisfy both equations. Okay, that's what the solution is. So the x and y values are going to be the same for both equations, and it'll make both equations true. Now that's going to make more sense when we look at a real example. Okay, so let's turn our attention to the first question. It says, create a linear system to model this situation. The perimeter of a Nunavut flag is 16 feet. I should change that to Canada flag. Hey? Its length is 2 feet longer than its width, because this is not the Nunavut flag. It is a Canada flag. Okay, so let's look at those two statements and see if we can come up with two equations. Okay? Perimeter is 16 feet. Those are the important parts of that statement. So let's think about this. We're going to need to incorporate some variables. Right. We said that it was two equations with two variables. So our two variables, what do you want to make them? R and
J.
R and J?
It's my initials.
For Rachel and Jared?
Actually, I was just thinking it's my initials, but I realized it was J.
Okay, we could make them R and J. So I'm going to make R and J. So R is going to be our width, and J is going to be our length of our flag. Are you okay with that idea? So first we've labeled our variables. Our variables R and J. R is the width, and J is the length. Now, in general, I would say it's a good idea to make your variables match what their definitions are. So to make it less confusing, I might have put W for width. And what would I have done for length? L. Does it really matter? No, but it'll just help you keep track of things better. So is this also a length down here?
Mm-hmm.
Yeah, so I'm going to put J there, and I'm going to put R there. Okay, now we've got our variables, we know what they are. We can start to write an equation. So we're going to start with our first equation. Perimeter is 16 feet. Okay, so I know that something is equal to 16. Okay, but what is perimeter? Is it R times J? Is that perimeter? That would be area, right? So if we want perimeter, we're going to, okay, the whole way around. And if I wanted to write that in terms of my variables, I would write R plus J plus J. R plus J plus J. Okay, I could also simplify that a little bit. Like I could go 16 equals 2r plus, good, 2j. So that's my first equation. 16 equals 2r plus 2j. Now I have another statement there, and it says its length is 2 feet longer than its width. Okay, that means my j is going to be like plus 2 feet, right, compared to my width. So I'm going to write j is equal to my width plus 2. Now we could check that in our brains and make sure that statement's true. Say my r is 4 feet. Okay, r is 4 feet. What does that make? So my width is 4 feet. What does that make my length? 4 plus 2, 6. Is my length 2 feet longer than my width? Yes. So that statement is true. I double checked it to make sure it makes logical sense. And now I have 2 equations. That's really all I'm looking for today, is to be able to write the 2 equations. We're going to learn how to solve the 2 equations in the next couple of classes using substitution, graphing, and elimination. But for now, we just want to be able to write these. Okay, I'll give you a second. Can you think of the 2 numbers that work for this, for r and for j? 2 numbers that we can plug in for r and j to make both of these statements true, both of these equations true. And right now you can just guess and check.
You could do r, because that has to equal 16, right?
Yeah.
So you could do like 10 for r.
Okay?
Well, like, as the,
This part equals 10, and this part equals,
4, but then you add 2.
you have to multiply by 2, yeah.
So maybe like 16.
Yeah.
I don't know, that's why.
You're on the right track. If this part equals 10 and this part equals 6, then they'll equal 16. And in fact, the answer for r and j is 5 and 3. Okay, so 5 times 2 is 10, and 2 times 3 is 6, so we get 16. Okay, that is true. And if we plug those same variables in for r and j in this equation, 5 and 3, right? 5 equals 3 plus 2. Is that statement also true? 5 does equal 3 plus 2. So what is our r? Our r value is our width, and it is 3. And our j value is our length, and it is 5. Cool? You're not going to be asked to solve them today, but you are going to be asked to write those 2 equations down. You're going to develop those 2 equations for your system of equations. Okay, we're going to move on to the next example. Okay, so this one says, create a linear system to model this situation. The perimeter of an isosceles triangle is 36 centimeters. The base of the triangle is 9 centimeters longer than each of the sides. Okay. Let's start by drawing a picture of a triangle. So what is an isosceles triangle? The word iso means the same, and isosceles has 2 sides the same. Equilateral triangles have 3 sides the same, and 3 angles the same. But isosceles, 2 sides the same. Okay, so I'm going to draw a triangle here that has 2 sides the same. I'm going to call this side and this side the same. And again, we're dealing with perimeter being 36 centimeters. And I'm going to call this side S. And this side is the same, so it's side S as well. And then it says the base is 9 centimeters longer than the two equal sides. So I'm going to call this side the base. Let's write an equation for this one. So I have my triangle, and I want to write a perimeter equation. So my perimeter equation is going to be 36 equals
2s
yep,
plus b.
2s plus b. And that time, you did a good job of just skipping the s plus b, and you just went 2s plus b. So that's great. That's our final equation. Perfect. And now the next part says the base of the triangle is 9 centimeters longer than each of the equal sides. So now let's compare the sides to the base. So our base was equal to a side plus 9 centimeters. Let's try that out in our head and make sure that it works. Okay, what if our side is 10 centimeters? It would be 10 plus 9, 19. And would 19 be 9 centimeters longer than 10? Yeah, so our base is 9 centimeters longer. That's the correct equation there. So I've got my equation 1, I've got my equation 2. I have now my system of equations. See if you can solve this one again in your head by just trial and error plugging in the numbers. Okay, this is not one of the strategies we're going to learn, but you may be able to do it for this one. It's a little trickier than the last one. Okay. In fact, the base is going to be 18, and the two sides are each going to be 9. So let's see how that works when we plug that in. 36 equals 2 times 9 plus 18. What's 2 times 9?
18. Oh, 18.
Yeah, 18. So we get 18 plus 18. 36 equals 36. The two sides are going to be equal. Check. And over here, if I plug 18 and 9 in, 18 for the base and the side equals 9, I get 18 equals 9 plus 9. That is also a true statement. Okay, so our variable b, well, I'll do lowercase b here. Our variable b for our base is equal to 18, and our variable s for side was equal to 9. Okay. Pardon? I missed a spot. The next one, create a system, a linear system to model this situation. A collection of nickels and dimes contains 4 times as many dimes as nickels. The total value of the collection is $20.25. Let's see if we can write a situation. This time we're not dealing with perimeter, but we have nickels and dimes. And there's 4 times as many dimes as nickels. So our first statement, first of all, I guess we should choose our variables, right? What do you want to choose for your 2 variables?
Jared, you pick.
Jared, you pick.
M.
Okay. N for nickels. And
D.
this is not rocket science. Yeah. So we got N for nickels and D for dimes. Now we want to write an equation for there are 4 times as many dimes as nickels. So the dimes are going to equal 4 times the nickels. So if I have 10 nickels, how many dimes do I have? 4 times 10, 40 dimes. And that would mean that there are 4 times as many dimes as there are nickels. 40 compared to 10. Okay, so that statement works. Now the next one, the total value of the collection is $20.25. Okay, so how are we going to figure out this total value thing? We have $20.25 is equal to, how much is a nickel worth?
No, it's 1 cent.
No, you're right.
No,
It's
it's
5 cents.
Jokes. I don't.
And then a dime,
10.
10 cents. Now, am I going to write 5 and 10? No, I'm going to write,
2.
okay, that is 5 cents, 0.05. Okay, and it's 5 cents and times the number of nickels. So if I had 20 nickels, that would give me $1.
I mean, 3 dimes.
Okay. So, and then plus the amount of money I earned from my dimes. Remember, each dime is 10 cents. So that's 0.10. You could have just put 0.1 times the number of dimes, right? So if I have 20 dimes, that actually gives me
There we see
$2. Okay, so that is our that's our system of equations there. One equation for 4 times as many dimes as nickels, and I have one equation for the number of nickels here. Okay, I'm not sure I'm going to be able to figure this one out in my head. It might be, let's see, 515. Let's do a little math here. Where's my calculator? Oh, my calculator's on my phone.
Do you want my calculator?
Sure. Okay, I'm going to solve this one by substitution. I'm going to teach you this next class, but you don't have to worry about it this class. So I'm actually going to substitute 4n in for d. I'm going to substitute that in there. And then I'm going to 20.25 equals 0.05 n plus, and then 10 cents times 4n will give me 0.4 n. Now I'm going to add these two n's together. 0.45 n is 20.25. And now 0.45 n, I'm going to divide by 0.45 on both sides. So I go 20.25 divided by 0.45. And that gives me a value for n that is 45. Okay, so I know n is 45. Doesn't seem right because that's only going to give me $4.50. Try that again. Oh, that's my number of nickels. Okay? So that's my number of nickels, 45. And then my number of dimes is going to be 4 times my number of nickels. So 4 times 45 will give me my number of dimes, which is
0.05.
180. So my final answer here would be the number of nickels is equal to 45, and the number of dimes is equal to 180 dimes. Okay, and that would work both ways. 4 times 45 equals 180, and then if we plug it into the second equation, 45 times 5 cents plus 10 cents times 180 will give you $20.25. Okay, but what you're really working on today is just being able to write this equation and that equation. You don't have to solve it. Okay, so as long as you can come up with those two equations, you're good for today. Okay, I think we have 2 more examples to work through. And we're running out of time, so I'm just going to write the equations for this one. We're not going to solve it. Create a linear system to model this situation. Sherry operates a grass cutting business. She charges $19 for small lawns, $29 for large lawns. In one weekend, Sherry made $287 by cutting 13 lawns. Okay, so Rachel, this time you get to pick the 2 variables. Okay, so what do you want for your variables?
We can do C and B.
C for...
Oh.
What are we?
I don't know.
Okay, C for small,
Sure.
and B for
Large.
large, B for big. How about we use S for small and L for large?
I'm not good at this picking variables thing.
Okay, so small lawn and L for large. Okay, now we got to come up with our statements, okay? Our 2 equations. So there's one equation that's kind of hidden here, okay? And there's normally you have one equation for one sentence and one equation for another sentence, but the 2 are kind of intermixed. So this is a little bit more difficult. She says she made $287 and she cut 13 lawns. So S is the number of small lawns and L is the number of large lawns. Could we write an equation just for cutting 13 lawns?
Or the big or large?
Doesn't matter, the total is 13 lawns.
Oh.
So this is a very common equation, you're going to see it a lot. It's like S plus L equals 13. Okay, the number of small plus the number of large equals 13 lawns. That's how many lawns she cut. And the other equation that's very common is the total, like the amount of money. So 287. Okay, and it's usually 287 equals the rate. So here's the rate. In the last question, the rate was like 5 cents or 10 cents. This time the rate is $19 per small lawn. Okay, and then what do you think we're going to write for the large lawn? 29 L. Okay, so she gets $19 per small lawn and $29 per large lawn. So if she cuts 2 small lawns, she makes $38 there. And if she cuts 2 large lawns, then she gets $58 there. That's not going to quite cut it. But those are your 2 equations there. Okay, one of them is just the number of small lawns plus the large lawns equals 13, and the other one is the rate for a small lawn and the rate for a large lawn is going to equal your total $287. Okay? Getting better at this? do one more. Perimeter of a rectangular playground is 163. The length is 6 meters less than double the width. Okay, Jared, it's your turn to pick the variables. What do you want? L for?
This one.
This is getting easy to pick variables now. Okay, and W for width. Bear in mind. So now we have two statements here. The perimeter of the rectangular playground is 163, and the length is 6 meters less than double the width. So here we have our playground, and here we have a width and the length. So the equation of the perimeter, 163, is equal to, okay, that's good, Rachel, 2L plus 2W, just like in the flag question, right? L plus W, that gives us our perimeter all the way around. And the length is 6 meters less than double the width. What do you think about that one? Can we write that in variables? How would we write double the width?
Just like double
So it would be
4.
2 times the width. That would be double the width. Okay? But it's 6 meters less than double the width. How do you do 6 meters less? You subtract 6, right? That's 6 meters less than double the width is equal to the length. Okay. So those are our two statements. Got to get good at doing this. This is the entire chapter 7. Okay, if you can't write these statements, then you can't do the math. Okay, thanks for joining us. We'll email this to you shortly, and I hope you had fun on your field trip.